Friends, subscribe my channel Netbook of Physics and press bell icon for latest update.
In this session, we are going to discuss few problems based on conservation of energy. So let's read our first problem. It says a rocket is launched vertically from the surface of the earth with initial velocity of 10 km per second. How far above the surface of the earth would it go? And we have been provided with radius of the earth as 6400 km, acceleration due to gravity 9.8 meter per second square. So when a rocket is launched with a velocity, it means it has some initial kinetic energy which we are providing to the rocket, and this kinetic energy will cause the gain in the potential energy. So we can write initial question number 1 as initial kinetic energy will be half times mv square, where m is the mass of the rocket and v is the velocity of the rocket, that is provided 10 km per second. Now gain in potential energy, the gain in potential energy will be when it is going up to a certain height h, the value of the potential energy will be gmm divided by r plus h minus the initial potential energy when the rocket was at the surface of the earth is minus gmm divided by radius of the earth. So the initial kinetic energy we are providing to the rocket must be equal to the gain in potential energy from the conservation of energy principle. So we can equate half times m into v square equal to minus gmm divided by r plus h plus gmm divided by r. So we can cancel the mass over here. Now we can restructure this equation as half times of velocity square equal to, we can take gm as common, we can write 1 by r minus 1 by r plus h. Now from this particular equation we know every term, that is g is known to us, the mass of earth is known to us, the value of the capital R is known to us, even we are provided with the value of g. So we can replace the gm with the acceleration due to gravity. So we know g equals to gm divided by r square. So I can write gm to be just gr square. So that will be half times v square equal to g r square 1 by r minus 1 by r plus h. Now using this equation we can easily calculate the value of h. Now using by simple calculation we can write r plus h divided by h equal to 2gr divided by v square. Now from this equation you have to calculate the value of h, and this we can further simplify and just put the value of r, g and v which are already provided in the numerical. We can calculate the value of h to be 2.5 into 10 to the power 4 kilometer. So the value of the h that will come out from this equation will be 2.5 into 10 to the power 4 kilometer, because we already know the value of g, the value of r as well as the value of v. The three variables we already know. So this is the way how to solve the problem using the conservation of energy principle. Now let us look at the second problem. It says show that the velocity of a body released at a distance r, small r, from the center of the earth, when it strikes the surface of the earth, its velocity is given by square root of 2 capital G capital M 1 by r minus 1 by small r, where capital R is the radius of the earth and capital M is the mass of the earth. Also it asks for also show that the velocity with which the meteorite strike the surface of the earth is equal to escape velocity. So this problem can also be handled with the conservation of energy principle. So it says that the velocity of the body released at a distance small r from the center of the earth. So it says that when the body was situated at the distance small r from the center of the earth, it was at rest. So it means at that moment it was having only potential energy, having no kinetic energy. So initial energy, question number 2. So initial energy equals to potential energy only initial equal to minus, it will be minus gmm divided by r, where m is the, let us assume the small m is the mass of that body and capital M is the mass of the earth and r is the distance between them. In this case, why we can write? Because kinetic energy is 0 because the body was at rest. Now when it strikes the surface of the earth, it will have both the kinetic energy as well as the potential energy. So final energy will be kinetic energy plus potential energy, and that is, I am just writing is that E suffix F equals to half of m v square minus g m m divided by capital R, where capital R is the distance between the body and the center of the earth when it just strikes the surface of the earth. Now from the conservation of energy principle, we can equate these two equations. So this will be half of mv square minus gmm divided by capital R equals to minus gmm divided by small r. So from this expression I can cancel the m both the sides. I am left with half of v square equal to, if we take the gm to that side, it will be gm capital M 1 by r minus 1 by small r, and we can write v equals to square root of 2 gm 1 by r minus 1 by small r. So this matches with the expression of the velocity which has been asked for. So this is the particular velocity with which the body, when released from a particular distance r from the surface or from the center of the earth, and it strikes at the surface of the earth, it will have this particular velocity. Now it has been also asked for, also show that the velocity with which the meteorite strike the surface of the earth is equal to 0. Now to understand this, it's a very tricky one, it's a very easy problem, because what is the distance from the center of the earth to the meteorites? We can say the meteorites is located far beyond the gravitational extension or the extension of the gravitational field of the earth. So we can say for meteorites we can take r tends to infinity. Now if I put r tends to infinity, r as infinity in this expression, we are left with v equals to square root of 2 gm divided by r. Now this is the expression for the escape velocity from the surface of the earth. So this is equal to v escape. So we know, so for the expression of the v escape, we know it is root 2 gm by r, and that will be the velocity of the meteorite when it strikes the earth's surface. It is very huge. So we have solved the problem with the help of the conservation of the energy. We just equated the initial energy with the kinetic energy, initial energy with the final energy to get the value of the velocity when it strikes the surface of the earth. Now let us look at the third problem. It says an artificial satellite is moving in a circular orbit around the earth with a speed equal to half the magnitude of v escape. It means escape velocity from the surface of the earth. First one is determine height of satellite above earth's surface, and the second is if the satellite is stopped suddenly in its orbit and allowed to fall freely, find the speed with which it strikes earth's surface. So let us focus on the first part of the problem first. Determine the height of the satellite above earth's surface, and the condition is given that the velocity of the satellite, orbital velocity of the satellite, is half the magnitude of the escape velocity. So for the first part in the question number 3, the first part, we know the expression for the orbital velocity if it is moving at an height h above the surface of the earth is v orbital is given by root over of gm divided by r plus h. R is the radius of the earth and h is the height above the surface of the earth. Now it is equal to half the magnitude of the escape velocity. So we know the escape velocity expression is V escape at the surface of the earth is root over of 2gm divided by r. Here both the capital mass of capital M indicates the mass of the earth. So as per the condition imposed on the first case is this V orbital must be equal to half of V escape. So according to problem, V orbital equals to half of V escape. So we can write it as square root of gm divided by r plus h is equals to half of 2gm divided by r. So let us square both the sides. So it will be gm divided by r plus h equal to, if I square this it will be 1 by 4 and 2 gets cancelled, that is gm divided by 2r. So gm cancels both the sides and we will left with 2r equal to r plus h, or from here I will get h equal to r. So what is r? We know the value of r as the radius of the earth is given as r equals to about 6400 kilometer. So the value of h will be 6400 kilometer. So this is the value of the height h where the artificial satellite is revolving around the surface from the surface of the earth. Now let us look at the second part of the problem. It says, if the satellite is stopped suddenly in its orbit and allowed to fall freely, find the speed with which it strikes the earth's surface. So for this part of the problem, we need to apply the energy conservation principle. So when the satellite is revolving at an height h equals to r, the initial kinetic energy, so at that moment it was suddenly stopped. So at that time it was not having any kinetic energy, right? So initial total energy of the satellite is only the potential energy. So we can write number 2, second part as initial energy is equals to potential energy of satellite only, because the satellite is stopped. When it is getting stopped, it means the velocity is 0. So we can write it as minus gm capital M divided by r plus h, or I can write just as 2r because h equals to r. So this is the initial energy, total energy. Now final energy will be the sum of kinetic as well as the potential energy. So the kinetic energy is half time m v square plus minus of gmm divided by r. So by equating these two equations, we can write EI equal to EF, which from the conservation of energy principle, and I can write it as minus gmm divided by twice r equals to half of m v square minus gmm divided by r. So we are required to find the value of the velocity, find the speed with which it strikes the surface of the earth. Later we have assumed the speed to be small v. So I can write it as this m gets cancelled from both the sides and we are left with v square equal to v square by 2 equal to gm by r. This will come this side, and if I take common it will be half, because 1 minus 1 by 2. So this 2 gets cancelled and we are left with v square equal to gm divided by r. We know from the expression for the acceleration due to gravity on the surface of the earth, g is given as gm divided by r square. So I can write it as g into r. So I can write it as g into r. So the expression for the v will be square root of g into r. Now we know the value of g, we know the value of r. If we put the value, it will come to about 7.92 kilometer per second. So we have seen how we have solved the problem of this type of problem simply using the conservation of energy principle.